we have triangles in our picture, okay, the number one thing you want to try to think about is proving triangles congruent, okay? In the proofs we've done so far, if you remember I told you if there's just angles, okay, so we're not closing the figure off, you probably want to think about angle addition. If there were just segments and you weren't creating polygons with those segments, you probably wanted to think segment addition, okay? But now because there's triangles, you probably want to think about proving triangles congruent, okay? That being said, it does not eliminate the potential or maybe the need at some point to still use segment addition and angle addition, but the overall kind of governing procedure here, process, is to use triangle congruencies. So our goal right now is to somehow get to either side, 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 or side, angle, side, to be able to use one of those things. This question, they do a lot of the legwork for us. They do a lot of the preliminary congruencies in the given. Okay, so if you remember the 7 steps I taught you with going through proofs, write your given down and look at that given and see if there's any congruency statements that are explicit, provided without any thought on your part. And you want to draw that into your picture. Okay, so AB and DC end up being congruent. And then I want to go look at angle BAC. So angle BAC and then angle DCA. Those two things are congruent as well. Okay, so draw that into my picture. If you are negligent in drawing things into your picture, you are going to struggle mightily when it comes to the process of you having to look at your picture and use theorems, definitions, postulates to come up with an additional congruency. Because in all our congruencies so far, we need 3 things, right? We either need 3 sides or we need 2 sides and an angle. So there's 3 objects, 3 congruencies that we need. Right now, our given gives us 2 of those, right? There's no vocabulary, so we can skip that step. We go to our picture, and now we have to think about our picture. We have to think about how we can come up with one more additional congruent statement, okay? Whether it be another side or another be maybe other angles, whatever it may be, we got to be able to look at our picture and come up with those things, okay? So we know right now, just kind of using the information that we've dealt with, we know we can only use either side, 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 or side, angle, side to show triangles congruent. Those are the only tools that we have right now. My hopes are that you recognize that you have information that kind of aligns itself best to use what process? Which of those 2 things? Should I use side, 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 or should I use side, angle, side? Side, angle, side, right? Side, angle, side probably is, now maybe that won't always work, but looking at the things that I have, that's probably maybe the first thing to try, because you have an angle, right? If I wanted to use side, 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 there are 2 other things I have to find, because I only have one of the S's in my picture for side, side, side. Does that make sense? But for side, angle, side, I have, however you want to look at it, if you want to look at it, you have those 2 parts as being that side and that angle, and then this side and that angle, or you can say you have the last 2 parts, doesn't matter. But you need one more side, right? Okay? So it's kind of a good idea to think about, what process am I going to use? What tools do I have to show triangle congruency? And based off the information I have in my given and my vocabulary, what does the problem set itself up best to use? So this case is going to be side. We're going to try to use side, angle, side. So if it's going to be side, angle, side, the next side that I'm going to try to figure out has got to sandwich the angle, doesn't it? Okay? It has to surround that angle with the other side. So which segment, look at just this triangle on the left, which segment would sandwich the red angle with the other segment that we already had defined? Cameron? AB? AB is already, AB is this one. Okay, so I don't want to make any more remarks about that one. AC. That segment AC, I'm going to color it. Let's go make it red here. Hopefully we all realize or see that segment right there sandwiches the red angle with that segment that we've already talked about, right? So the hope, and when I say sandwich, because that's what's happening here when I look at side, angle, side. So they included angle. I'm going to try to see if I can talk about AC somehow. And because it sandwiches that angle there, does it also come over in this other picture, this other triangle, and does that segment right there sandwich the red angle and that other triangle? Does that kind of make sense to everybody? So the hope is that we can maybe make a comment about that segment AC. Does anybody want to make a comment about it or a thought about it? What can I say about AC in relation to itself? Fair? Okay, it does end up being a transversal for AD and BC. That's fine. That's not going to help us develop congruencies for triangles. What is it, if I gave you an object like 5? What is 5 always equal to? 5, right? Something is always equal to itself, correct? So is AC always equal to AC? So let's write that. And I'm not going to say equal, but I'm going to say congruent. AC is always congruent to AC. Okay? Now the reason I'm going to write that is because if I were to draw that in my picture, okay, AC is congruent to itself. So I put two marks in there to differentiate that it's not the same as AB and it's not the same as DC. But here's the logic of why I did that. If I were to take like a razor blade and cut down through AC all the way up along that segment, okay, and I pulled those two triangles apart. Well, those two triangles, let's see if I can draw it here. Okay, so that's kind of the picture that we had, right? Okay, and A would be, like A was there and C was there, right? Okay, if I take a razor blade and cut down that segment AC and pulled my two triangles apart, AC is there, and AC is also a segment in that triangle. Does that make sense? So, given the information that we had, we started off with that segment and that segment congruent, this segment, or sorry, that angle and that angle are congruent, and now we've shown AC is congruent to itself. And if I pull the triangles apart, you have side, angle, side, and then over here, side, angle, side. Does that make sense to everybody? Okay. So, using that reflexive property, that's what that statement is here. Well, that's the reason we can make that. Reflexive is the idea that anything is either equal or congruent to itself. Okay? Making that statement now provides me that third congruency that I need, now allowing me to say that the two triangles are what's going on. The two triangles are congruent. So I'm going to say triangle ABC is in fact congruent to triangle CDA. And the reason is always going to be, what was that order of parts that you recognized? You recognized side, angle, side, right? So SAS is going to go right there. Okay? Whenever you make a congruency statement about triangles, this is 100% of the time, whenever you make an argument that looks like that, your reason will be either 3 letters or 2 letters. Okay, it's going to be something like side, angle, side. Eventually, it could be side, side, side. Could be angle, side, angle. Could be angle, angle, side. Or it could be hypotenuse leg. Okay, so that would be the situation where it's not 3 letters, it's 2, it's HL. Okay, and we'll get to those other statements. But whenever 2 triangles are congruent, your reason will always be some collection of the letters S and A. Okay, and then every once in a while H and F. Okay. Does that kind of make sense, everybody? All right. The reason I showed you this proof, and it's not very long, it's only 3 steps. It gave you a lot of the information, but one of the key things, and this happens a lot throughout the process of proving things congruent, not just triangles, but you're going to need that idea of seeing reflexive segments or maybe reflexive angles showing up in pictures. Okay, so that's what this proof kind of gets at. Can we recognize that? Whenever we see something being shared completely, okay, 100% of the object is being shared by both triangles, we want to use the reflexive property. That kind of makes sense? Okay. And what I mean by completely, sometimes we'll deal with angles. Okay, and if I want to maybe look at that triangle there, and then I have another triangle, kind of maybe overlap like that. Okay, there are some angles there that might be being shared, right? Okay, would you guys agree? Or overlapping. That angle right there for that big triangle, and then that angle right there for that one that's kind of this triangle here. Does that make sense, everybody? Are they overlapping 100%? No. Okay? And if I pull them apart, the idea is that this triangle here, this angle here, is not the same thing as this whole angle there. Does that make sense? So reflexive property, it's the entire segment being shared by both shapes, or the entire angle being shared by both shapes. So when I say that phrase, that's what we want to be thinking about.